Hello. Today we're going to focus on chapter 1, Foundation for Algebra. In this chapter, we're going to cover how to evaluate and simplify expressions, know the different properties of the real number system, know the order of operations, and also learn the patterns formed by points plotted in coordinate plane. Today, we're going to focus on section 1 of the chapter that covers variables and expressions. Before we start, let's recap the vocabulary required to know throughout your algebra journey. What are variables? Variable is a letter or a symbol used to represent a value that can change. So a variable can have any value. For example, let's take the example up here. X plus 5. So x is a variable. X can have any number. It can be 1, 2, 10, 1,000. It can be any number. It is not a fixed or a constant value. So it is a letter used to represent a value. Let me type it so you can better read it. It is a letter used to represent a value. Okay. Next, a constant. A constant on the opposite of variables, which is fixed and has a constant value. A constant can never be manipulated or changed or altered. For example, in the above example, as you can see, 5 is a constant. 5 is a value that cannot be changed. Constant is a value that does not change. Now, what's a numerical expression? Well, it contains only constants or operations. A numerical expression that may contain only constants or operations. Now you may ask, what are operations? Operations are arithmetic operations, as you have seen here. Add, subtract, times or multiply, and divide by. So numerical expressions can only contain constants or operations. It will not have any variables. On the other hand, algebraic expressions may contain variables, constants, or operations. So let me erase some stuff. So as you can see, this is an example of a algebraic expression. X plus 5 is an example of an algebraic expression. It contains a variable, it contains a constant, and it also contains an operations. As it said, algebraic expressions can contain variables or constants or operations. They don't have to be all in the same expression. So x by itself is an algebraic expression. A constant 5 can just be an algebraic expression as well. So this is an example of an algebraic expression, but not a numerical expression. Well, 5 is both an algebraic expression as well as a numerical expression. I hope you have understood the different vocabularies used in algebra. So now let's move on to the next topic. So just to recap, what are operations? Again, plus, sum increased by, minus is the difference between two numbers, less than, times is the product of two numbers, equal groups of, and divide by, where you find the quotient of the two numbers. Well, as you may know, that algebra is not theory, it's more of practicing problems and solving equations. So now let's practice how to translate an algebraic symbol to words. So let me introduce a new page. Okay. X plus 3. Now, this is an algebraic expression. How would you express this algebraic expression in words? Let me start. The sum of x and 3. This is one way of expressing in words. Another way that we could express this expression is by saying x increased by 3. Let's take another example so we can better understand how we could translate algebraic expressions in words. Okay. K divided by 1. Well, I just said it. So let's write that in words. K is divided by 1. Or we could say the quotient bear with me, of k and 1. These are the two ways we could express this expression in words. Now let's move on to translating words to algebraic expressions. Let's take a word problem. Let me scroll all the way on the top. Let's take this example. Okay. Eve reads 25 pages per hour. Write an expression for the number of pages she reads in 8 hours. So let's solve this word problem together. Okay. H here represents, yes, it is a variable, and it represents the number of hours that Eve reads. $25 times H, or we could say 25H. Let's think it this way. 8 groups of 25 pages. So she read 25H pages in 8 hours. All right. Now let's move on to the next example. Okay. William runs a mile 25 in 12 minutes. Write an expression for number of miles that William runs in a minute. Let's think it. How many groups of 12 are in M? I didn't mean to do that. Well, let 1 hour, she covers 25 pages. B the total multiplied by William runs. Okay. So M over 12. This is the expression for this question. Now let's move on. Before we recap and practice, there's one more vocab, that is evaluate. Evaluate, it is an expression used to find its value. To evaluate means in an algebraic term is to substitute numbers for the variables in the expression and then simplify the expression. So when we say evaluate this expression, for example, this one, and let's say n is 1. So now if we substitute 1 to m, so this expression becomes 1/12. And this is how you evaluate. So here m is a variable and m can have any numbers. So m can be 2. And then that can be, so the expression changes to be 2/12. Hence it becomes a fraction. And that's how you evaluate an expression. Okay. Let's do another example on evaluating algebraic expressions. Okay. Let's say x is 8, y is 5, and z is 4. X plus y. How would you evaluate these expressions? Let's substitute x plus y. So as you can see, x is 8 and y is 5. 8 plus 5 equals 13. And this is how you simplify the algebraic expression. Now let's take another example. X over z. We know that x is equal to 8 and z is equal to 4. So we just have to substitute those values. So x is 8 and z is 4. And if you simplify that, we get 2. And this is how we evaluate an algebraic expression. Okay, now let's move on to recapping and solving more problems. So let's test our vocabulary. An or is a value that can change. Could it be algebraic expression, a constant, or a variable? Please pause this video and think about the answer. Okay, I hope you could have figured out the right answer, I'm sure. So, what is a value that can change? It is a variable. A variable can have any values. It's not a fixed value. Whereas a constant can change. It cannot cannot change. It cannot have just any number. It is a fixed value that does not change. And an algebraic expression that contains a variable, constant, or operations, it's an expression. It's not just a value. So in this definition, variable goes well. So the answer is variable. A variable is a value that can change. All right, let's move on. Josh drives at 45 miles per hour. Write an expression for the number of miles Josh travels in H hours. What would you say? Think H hours of 45 miles. Okay. So let's take age hours. So 45 times age. So each groups of 45. Or 45 times each. Well, I hope you guys have got this answer as well. Okay. Next is convert the expressions to words. C plus 15 is one way of writing it. Another way you could say C increased by 15 works. Or we could say the sum of C and 15. Okay, next, x over 12. Or we could say x divided by 12. Or we could say the quotient of x and 12. Okay, now let's move on. Let's evaluate these two algebraic expressions. It's given that A is equal to 3, B is equal to 4, and C is equal to 2. So A minus C. So let's substitute the values first. So 3 minus 2 is equal to 1. And that's it. Next algebraic expression, I would like you to pause this video and solve it by yourself. Okay, I'm sure you guys have paused it and solved it. So let me do real quick. Okay, so B is 4 and C is 2. Or we could write it as 4 over 2, which is 2. And this is how we evaluate algebraic expressions. Okay. Let's move on to the final question. I have already done the solution below, but I would like you guys to solve this by yourself first. Okay. I hope you guys have solved this solution. Let's go over it together now. Brianna practices the piano 30 minutes each day. So question A, write an expression for the number of hours she practices in D days. Well, you see, there is something missing here. It says write an expression for the number of hours. So it's asking in hours, but we are given in minutes. So first, let's convert the unit. So we match the unit. So as we know that 1 hour is 60 minutes times 30 minutes, which is half hour or 0.5. Now it says, write an expression for the number of hours she practices in D days. So think it of as like, how much D groups of 0.5 hours. So it's 0.5 times D. That is the number of hours she practices in D days. As you can see here. So in one day, she reads 0.5 hours. So in D days, she reads 0.5 times D hours. Let me write the unit as it is in practice. So now, find the number of hours Brianna practices in 2, 4, or 10 days. Now it's just substituting the value into the expression. So our algebraic expression is 0.5D. So what is her hours when she reads in 2 days? So 2 days, she would read, just substitute the value of D, which is 2, 0.5 times 2, which is 1. She reads for 1 hour for 2 days. Next, the question asks 4 days. So how much hours would she spend reading in 4 days? So 0.5 times 4, which is 2 hours. Well, you write for shorthand, you write for hours as HR. And then the final is 10 days. How much would she cover? How much hours would she cover in 10 days? So 0.5 times 10, which is 5 hours. And this is how you solve this problem. I hope you guys have understood the section 1 of the first chapter. Thank you.